At the University of Washington, I direct the Ubiquitous Computing Research Lab. We're a computer science and electrical engineering lab focused on hardware and software solutions to really solve interesting and socially meaningful applications.
So the goal of this research is to basically solve real-world problems. So we actually look at the world and say, all right, what needs to be solved, and then can we actually find an answer to that problem?
So what we're trying to do is not just theoretical. We use a lot of theory in our solutions, but we're computer science researchers that really have a human focus.
One of the major focuses in our lab is sustainability sensing. So in particular, we are looking at how to give homeowners information about not just how much energy they're consuming, but exactly where that energy is going, how they're using it. So in particular, we've worked on electricity, water, and gas.
And it uses computer science, machine learning, and signal processing to distill down what device is running in your house at that moment. And so at the end of the month, we actually get a breakdown of your electricity and water usage. We can provide people actionable feedback on what they could do to reduce their energy consumption. A second area that the lab focuses on is on low-power wireless sensing. We've been promised this vision of the smart home for many years. And one of the challenges with the smart home is that you can imagine sensors being deployed throughout the space. But one of the biggest challenges is battery power. And so that's one of the projects that we've been working on, is building sensors that are so low power and that you don't have to worry about replacing the batteries. And the idea behind this is it enables us to put sensors in places that you don't have to worry about retrieving. So it could be built in behind a wall, it could be thrown in a crawl space in an attic, where you could detect things like mold, humidity changes, leaks, to really try to do safety and hazard detection in a home.
So another research focus of our lab is novel interaction. And the reason we are doing this is because very soon we are going to have computers all around us, embedded into the environment. And we need new ways of interacting with these that are not just a keyboard and mouse. What we have done is we are doing Kinect-like gestures, just a whole body free air gestures, anywhere in the home. But it does not require either you to wear a sensor on your body or putting cameras everywhere in the home. And the way we are doing this is we use wireless signals, just like those from your Wi-Fi router. So I have a quick demo here. So if what I'll do is I'll move my hand back and forth, and what you'll see is this light change colors. This doesn't have to be a light. This could be your television, this could be your heating, basically anything in your home. It could even be your music. Another area is security, home security. So imagine doing whole home motion detection without actually putting motion detectors everywhere in the home.
I like the fact that I can work on computers in ways that go beyond just the desktop computer, that can get used in all kinds of different parts of your life.
Another area of focus for us is in health sensing. And so the idea behind this is how can we use computing technologies to really have an impact in the health space. And so we've been focusing on using mobile devices, in particular mobile phones, as health sensors for a variety of different physiological information. So one example of this space is a project called SpiroSmart. So SpiroSmart is a mobile phone-based application that turns the phone into a spirometer. So a spirometer is a device that measures lung function. So if an individual has asthma, cystic fibrosis, COPD, or any other pulmonary ailment, what you do is you do a lung function test, which is a device you blow into, and it measures the lung volume. These are fairly expensive devices. You have to go into clinic to use this device. And so what we've done is built a software solution on a mobile phone where it uses the microphone as a sensor.
So it graph basically shows the volume on the x-axis and the flow, basically the rate at which air is coming out of your lungs, on the y-axis. All the data that SpiroSmart is collecting and the users are testing goes to this interface, and the doctors are able to track how patients' lung function is tracking over time.
So the vision of this health sensing research is really trying to reduce the overhead of how often, obviously, patients have to go back to the hospital, to reduce the number of visits, to reduce the cost of healthcare, but also increase the quality of healthcare.
A lot of our projects very much focus on having something that will be useful to the world, as opposed to purely developing something for development's sake.
This research is important because it really shows what the impact of what computer science and electrical engineering can have on people's daily lives. We're doing this great work in the lab, but a lot of times people can't relate to it into their daily lives, and what we're doing is trying to solve real applications, and so people can actually benefit from this work.